Hi, I'm Mike, and today I'll be demonstrating a method for adding a delay to the triggering of the Q109 envelope generator from synthesizers.com. While there are many ways to accomplish this with a modular synthesizer, I'll show you a simple method using modules that you're likely to already have in your system. So there's many occasions when a delayed trigger is musically useful. Probably the most common application is for delayed vibrato, and while some envelope generators, including a delay feature, the Q109 does not. So we will create our own using other modules. First, let's look at the System 44. I'm going to describe the modules that I'm going to use today. First, we have a Q106 oscillator here. It's going to generate a note every time that we press a key on the keyboard. This oscillator range is set to 32 feet and will produce a relatively low pitch. The oscillator is getting its control voltage into the 1 volt per octave input right here, the usual way from the MIDI interface. And we'll use the saw output right there to hear its frequency. Next, way over here we have a Q109 envelope generator that we use to vary the pitch of the Q106 oscillator when a key is struck. Q109 output right here is connected to the Q106 exponential input right here. And the level knob is set to produce a 1 octave increase in pitch when a note is played. So that level setting has been adjusted to produce an octave pitch increase when a key is struck. Varying the settings over here on the Q109 will actually end up slewing the pitch of the Q106 oscillator. So first I'll play a few notes on the keyboard so we can hear the effect. I have both the attack and release of the Q109 right now at 0, and I'll change it so you can hear exactly what's happening. I'll add some attack. And I'll add some release. So you can hear that the note starts low, goes up an octave, and then returns back down, and that's all being controlled by the envelope generator. So that's an interesting effect, but that's not really what I want to accomplish. What I would really like to do is have some delay between when the note is first played and then when it slews up to the higher frequency. So I really need a delay function, and my envelope generator doesn't have that. So what I'm going to do is I'm going to change the setup and add a second Q109 envelope generator in the patch to create the delay. Start by adding a patch cord from the keyboard gate into the gate input of the delay of the Q1. I'll call this the delay Q109, the one right next to the other Q109. So we need to get a gate signal into here, and I'll do this just by stealing the gate signal from the other one and just putting it right in here. So now it has its gate signal. And then I'll add a patch cord from the delay Q109 output right here into the gate input of the other Q109. There. On the delay Q109, we'll start by setting the attack to 0, delay to 0, sustain to 10, and release to 0. So 0, 0, 10, 0. I'll play some notes again. And as you can hear and see, it's really the same result that we were getting before. And also note that the LEDs on the Q109s, which indicate when they're coming on and going off, are more or less coming on and going off at the same time. There's a little delay because of the release time. If I set that back to 0, you can see what's happening. Okay, so now let's add delay by slowly turning the attack time on the delay Q109 up from 0 while repeatedly playing a note. So as you can see, as that attack time is increased, it ends up turning into a delay for the start of the Q109. Now, as a bonus to this setup, I can actually adjust the release time on the Q109, and it'll actually affect when the release of the envelope generator starts. And I'll demonstrate that here. First, we'll set attack back to 0. Now I'll increase the release time. So using this method, with the attack turn all the way to 10, will give you about 2 seconds of delay. And turning the release all the way up to 10 will give you about 6 seconds of release. So a fairly simple patch. The envelope generators are right next to each other, which makes it very convenient. So let's just discuss briefly how this is actually working. So the Q109 envelope generator starts its attack segment when a signal input at the gate input right here gets above about 1.5 volts going positive. The Q109 will start its release segment when the gate signal then falls below 1.5 volts. Now normally we run a gate output from a MIDI interface like the Q104 that I have, or the Q174, which is a newer version of the MIDI interface, directly into a gate input. Those gate signals coming from the MIDI interface vary between 0 volts with no key pressed to 5 volts when a key is depressed. And those gate signals are rising and falling very, very quickly, and therefore we don't hear any delay between when a key is pressed and when the Q109 starts. So that's kind of the classical way to trigger a Q109. By adding this delay Q109 before the envelope generator and using its output as a gate, the gate is actually no longer rising as quickly when we increase the attack time of the delay Q109, and therefore it takes longer for that gate to reach the necessary 1.5 volts to start the Q109. Similarly, increasing the release time of the delay Q109 causes the gate signal to take longer to fall to the required 1.5 volts. That will then start the release segment of the Q109. Because of the classical shape of the ADSR envelope, the delayed attack will end up being shorter than the delayed release, which is why we could only achieve about 2 seconds of delay with the attack, but we could achieve 6 seconds of delay for the release. For most musical applications, a 2-second delay is probably sufficient if you're playing notes on a keyboard. However, if you require longer delays, we can make a simple change to the setup to accomplish this. Okay, now we'll add a Q125 signal processor between our two envelope generators. We'll only need to use the lower offset section of the Q125. Here's a Q125. We're just going to use this lower section down here. And first what we'll do is we'll patch the output of the delay Q106 to the input of the Q125 right in here. So we'll take the output here. Let's remove this patch cable. Going to need a longer one. Take the output and patch it to the input of the Q125. And then patch the output of the Q125 to the gate of the Q109. Go to the output, into the gate. So now we've inserted the Q125 in between the two envelope generators. The Q125 mode set to normal, right here, and offset to 0. And let's change our parameters back to what they were originally on the envelope generators. We'll get the same effect as before. Now, while playing a note and holding it, we need to adjust the Q125 offset in the negative direction until the Q109 LED just goes off. So we're going to watch this LED here, but while we adjust the offset here. I'm going to adjust that negative until that light just goes off while holding a key, and then just increase it slightly back until it just comes back on. So right about there. Now we'll play some notes and we'll increase the delay, and you should notice that we can achieve much longer delay times now. In fact, we'll achieve a delay up to 12 seconds using this methodology. Now, even longer attacks are possible, but it requires, again, different setups, and that may be the subject of a future video. But for now, that's it. Thanks for watching, and please feel free to leave a comment or any questions and any suggestions you'd like for future tutorial videos.